Okay, so to close out the limits, we're going to talk about one-sided and two-sided limits, okay? One-sided and two-sided limits. So we have, let's say that I'm looking at the limit as x approaches 0, 1 over x. Which graphs out like this. So if I was approaching 0, so as x goes to 0, what happens to f of x? What happens to 1 over x? It goes to positive infinity, right? So it's positive infinity. The problem is that if you approach 0 from the other side, okay, it's actually going to go down to negative infinity, okay? So this is what we call the one-sided and two-sided limit. So this has two different limits depending on where you're approaching that number from. So we make the designation of the plus here, and that means you're approaching 0 from the positive side or from the right-hand side. So if I approach 0 from the positive side, I'm going to end up going like this, and this is going to be infinity. Now, if I approach x goes to 0, but from the negative side, it actually goes down here, and we get negative infinity. Okay, so the plus and the minus signs here designate or denote which limit you're taking, whether it's the right-hand limit or the left-hand limit. Okay, all right. And if you look there, what does it say? Okay, approach from the right and approach from the left. We talked about that. The greatest, okay, no, we're not going to worry about that. Sometimes we call the two-sided limit if of f at c to distinguish it from one-sided, okay? So look at the theorem number 3. Function x has a limit as x approaches c if and only if the right-handed and the left-handed side are the same. So since these are not the same, the limit here does not exist. There is no limit here because at 0, because the one side and this side do not agree with each other. So there is no limit. Limit does not exist here, okay? So let's see if we can play around and do a question and see if we can make this stick for us. So let's go to example number 8. Example number 8. I have a function that looks like open dot, close dot, open dot, close, close, close. Okay, so it's going to be 4, 3, 2, 1, 0. So so at x equals to 0, limit as x approaches 0 from the positive side of f of x is equal to what? Can anybody tell me what the f of x, the limit is as x approaches 0 from the positive side? It's going to be what?
1.
It's going to be 1, right? It's trying to go to it's actually going to get to 1 because as x goes to 0. Since this is a closed dot, it actually is 1, right? So it's 1 right there. At x equals 1 from the negative side, what do I get? What is the limit here? As I approach 1 from the negative side, it's trying to approach what?
0.
Right? 0? It's 0. What about if I approach it from the positive side? 1. If I approach 1 from the positive side, it's going to approach what?
1.
1, right? So therefore, at 1, the limit exists or does not exist?
Does not.
Does not exist because they're different, right? What about 2? Let's see if we can, so when we go to 2, From the negative side, what do I get? From the 2 from the negative side, what does it try to become? What does it become? 1. Okay. What about from the positive side? What about the positive side? From the positive side, what does it get?
1 still.
It's still trying to approach, it's trying to approach 1, right? So the limit here at x equals 2 exists, and it is 1, because coming from the negative side or coming from the positive side, it's still the same. It's still going to try to approach 1, okay? Now the actual value of f of 2 is equal to what?
2.
Right? Because it's up here, this is 2, right? So the actual value is 2. The limit which exists is going to be 1. Okay? All right, let's move on to 3. What about 3? As it approaches from the negative side, what do I get? From the negative side, if I approach 3, what is the limit? 2, right? It's going to be 2. From the positive side, if I approach it, what do I get? I get 2 also. So whether it's a negative side or the positive side, it's both 2. So the limit does exist, and it is 2. And at this point, actually, f of 3 is equal to 2 also. So it actually corresponds to the limit. The actual value of the function corresponds to the limit. Okay, this one over here did not, right? And as you can see, we have a floating point here. We have a discontinuous point here. Okay. What about 4? 4, if I approach it from 0, what do I get? If I approach it from the negative side, 4, what's my limit? This is going to be 1, right? Because it's approaching from here, it's approaching 4 from the negative side. Okay. So that is the difference between the one-sided and the two-sided limit. Okay. And we'll do one more thing. It's called the squeeze theorem. It's called the squeeze theorem. The squeeze theorem on top of page 65 reads that if g of x greater than equal to f of x greater than equal to h of x, okay, for all of x equals not equals to c in some interval about c, and we know that the limits, if I took the limits here as x goes to c, limit as x goes to c, limit as x goes to c, all right? And I know that this guy here is going to be equal to L, and I know that this guy here is going to be equal to L. Well, this guy's going to get squeezed into, since both of these are going to be L, the limit here has to be L. It can't be nothing, it can be nothing more than that. Because I know that between L and L, the only thing in between can be L. Okay, that's why you're squeezing the f of x between g of x and h of x to state that the limit is L also. Okay, so what does this all mean? Let's go ahead and take a look at an example and see how we can do. Look at example number 9. Example number 9, it says, show that limit as x approaches 0, x squared sine 1 over x is equal to 0. Okay, so the way that we would approach this is this. I do not know about this so much, but I do know about one thing I know about this is what? I know that sine 1 over x is between 1 and -1, right? It's by definition, it's a sine function, so it has to be between 1 and -1. Okay. Now here, I'm going to go ahead and multiply everything by x squared. So I'm multiplying by everything by x squared, and I can do this because I know that x squared is positive. So I'm not going to change the inequality signs. I don't have to switch them around because they're positive. X squared is a positive number. Okay. Now, if I take the limit on both sides where x goes to 0, if I take the limit of this as x goes to 0, what does it become? It's 0 squared, so it becomes 0. Over here, I get negative 0 squared, so it's going to be 0 also. So this guy here gets squeezed from this 0 and this 0, so that I know, I can tell you that the limit as x approaches 0, x squared sine 1 over x is going to be equal to 0. Okay, so this is how you squeeze this guy in between these two to state that the limit is equal to 0. It's a little complicated, but shouldn't be too bad. And questions associated with this usually has to do, it'll tell you, well, to prove something using the squeeze theorem. So your thought process should go that way. Okay, all right, we're done. We're done for the day. So go ahead and, you got about 15 minutes left. Go ahead and continue to work on your homework and see if you can finish it up.